In this video, we will see what the differences between the two most popular GI approaches are and why we would potentially decide to use one over the other. When you render with Global Illumination in V-Ray, you have the option to choose a primary and a secondary GI engine. The two approaches we will explore involve either using the brute force engine as your primary combined with the light cache engine as your secondary, or the Irradiance Map engine as your primary in combination with the light cache engine as the secondary. The Irradiance Map and light cache approach historically has been a popular method due to the potential speed advantages, especially when dealing with still images. The Irradiance Map calculations could also be saved or added upon and reused on a later point. However, when it comes to rendering a sequence, achieving good-looking results with the Irradiance Map requires more in-depth knowledge and tweaking of the particular values. In recent versions of V-Ray, we have made major improvements, especially regarding the core speed optimizations. While previously the brute force engine was considered the most accurate, but also slow method of GI calculation, it has now been significantly optimized for speed. As a result, it is the default primary GI engine that we recommend sticking with for the most use cases, as it's not only the most accurate engine, but also it generally gives great looking results without the need for tweaking settings. Alright, let's start by making sure that our two sets of render settings are using the same anti-aliasing noise threshold and are set to their respective primary and secondary GI engines for the two approaches we will be comparing. There are only two values we are going to modify: the AI threshold value, which will increase to 0.05, and the material override checkbox, which we will check on. Now we will be able to do some test renders more quickly and easily compare the results of both GI approaches so that we can focus on the overall lighting without being distracted by any materials. We will leave everything else at their default settings. Now let's do a test render with both sets of settings and use the wide angle camera so we can capture a bigger part of the scene. I will speed up this part of the video so we can focus on comparing the images. Alright, the Irradiance Map render seems to have large splotches spread throughout the image. They are mostly concentrated on the large even surfaces due to the nature of the way the engine calculates the count and the placement of the necessary subdivisions. These Global Illumination artifacts are hard to clean up and can require a lot of tweaking to resolve. Since by default the Irradiance Map is calculated for each frame, these artifacts tend to create jittering or flickering during animations, which is an unwelcome distraction for the viewers. Let's load in an image I have pre-rendered from a camera looking straight down on the center of the scene, also using the Irradiance Map approach. From this shot, we can see the rather large amount of light bleeding in the render, as well as the lack of overall detail. The Irradiance Map is built to work adaptively, since not all of the objects in your scene contribute to the GI calculation the same way. For instance, large areas tend to get lit more uniformly, which might assign them with lower importance for the GI calculation, while objects close to each other tend to accumulate more detail, at least as far as geometric detail goes, and therefore the Irradiance Map tries to solve those parts of the scene with higher accuracy. As a result of this adaptive nature, some parts of the scene might end up looking less detailed than they actually are. Take a look at the blue lights surrounding the hero object as an example. The light coming from them is hitting a large and uniform surface, and therefore getting averaged so much that it starts to lose definition and becomes mushy. Lastly, let's take a look at a couple of close-up shots. Note how the small objects close to each other have greater detail in their lighting, and the large even surfaces need even more subdivisions to achieve similar results. To get the best results, you'll want to fine-tune your Irradiance Map settings and find the right balance for achieving a clean GI result. At this point, you might have to increase the overall Irradiance Map settings so much that they render at similar or even slower speeds than the brute force engine. This is heavily dependent on your scene and the amount of time you have available for tweaks. Now that you have seen how the Irradiance Map works, let's compare that with the brute force and light cache GI approach. As you can see here in this set of images, the brute force engine can deliver even more accurate results with little to no additional setup. As I already mentioned, thanks to the speed optimizations implemented in the recent versions of V-Ray, the brute force light cache combination is a suitable solution for most scenarios. Alright, now that we have explored these two global illumination approaches, let's move forward to explore more features in the upcoming lessons.